Let's quickly demonstrate SuperOptiX. You can find all the information about SuperOptiX, its features, pre-built marketplace, link to the documentation, and quick start guide. Now, let's start to follow this quick start guide. First of all, you need to create and activate your virtual environment and install SuperOptiX. In my case, it's already installed, so it's super quick. It might take some time for you. Then, you need to get some models already downloaded into your system, preferably with Ollama, but you can use any inference engine. For most of the playbook, we'll be using the Llama 3.21 billion model because this is the smallest model that can work on any machine. You can also list these models using supermodel list command, where you can see the models installed using various backend systems. So first of all, you need to initialize your agentic system. Let's call it a SWI. So let's do it super init SWI. So what it did basically, it created the SWI directory, and inside SWI directory, it created the full-blown package for your agentic system. So if you open it into your editor, you can see it created the Python package with all the necessary model needed to build your agentic system. As you can see, there's nothing in the agents, so we need to grab some agents. So you can get the agent using marketplace straight away, or you can build from scratch using SuperSpec. For this demo, we'll get it from the marketplace. We can pull the developer agent from marketplace. So now what it did basically, it created a playbook file for this agent that we can see into our editor. So this is important file because this is the file where you will be doing most of your context engineering, providing the context to your agent. As you can see, it has a configuration for language model, persona, the task, and most importantly, this feature specification or scenarios. So these scenarios act as your executable specification or example that can be used for evaluation. Next thing, we need to compile this agent, meaning we need to create the pipeline for this agent. So we can create a pipeline for developer agent. So if you see now, the SuperOptiX has created the fully working DSPy pipeline for this agent. We don't have to go to the details, but this is totally working pipeline automatically created by SuperOptiX. If you're DSPy expert, then obviously you can dig into deeper and then make this pipeline even more optimized and further improve it. But for now, let's keep it as a default. Next, let's evaluate this agent. In evaluation stage, what happens is basically all the scenario that we specified in the playbook is compared against the model output. At the moment, everything is failing because we have not used the greatest model, but if you use the bigger model, it might pass. Or you can make it pass using your adding more examples. Next, we will optimize this agent. In optimization stage, what it does is create the JSON files with all the demonstration that will be used for the DSPy optimization. And the last step is you run this agent. So you run this agent using run command and give it a go. Now you can see the agent has worked well, performed this task, and given this output. Now let's get in a couple more agents into our system. So we will get DevOps engineer and we'll get QA engineer. Now if we list those agents, you can see 3 agents one is fully optimized, other one are just in playbook status. You can also see those agents inside our project. Let's compile them all. Meaning we are automatically creating the pipelines for those agents. So now you can see the pipeline has been automatically created for those agents. So now we have 3 agents running. So let's say the list again. So those agents are now compiled. Now let's create a orchestra so that we can orchestrate these agents together. We can create an orchestra using SuperOptiX create command, and let's call it SDLC, or software development lifecycle. As you can see here, what happened is it created the simple orchestra YAML file where it created the sequential orchestra, and the task for the agent is defined in this orchestra file. Obviously you can change it, but for now let's keep it as default. And finally we run this orchestra. Let's give a goal so that they can be performed by all these agents in the orchestra. Now it's running the orchestra, passing the output of one agent to another agent and performing the task. And once it's done, all the things is written to the orchestra workspace. So all the agent outputs are written to the workspace, as you can see written in this file. You can also see there are some traces generated, which is stored into the SuperOptiX traces directory that you can use it for observability. You can check these traces using super. Will list all the traces, and also you can analyze those traces for specific agent using super observe analyze, let's say for developer, and you can see how many traces generated, and you can get more information about the traces. So we have covered a lot. We have created the agent, we have optimized the agent, we have evaluated it, and also we created the multi-agent orchestra. We also seen some traces of this agent. So this is all about for this demo, and this is just a start. If you have any feedback, just drop me a line. Thank you.